Good evening, students. In module 2, we learned properties of systems. In continuation with properties of systems, we now learn time domain representation of LTI systems. LTI systems here means linear time invariant systems. A LTI system can be represented through or input and output of LTI system can be related through convolution sum or convolution integral or impulse response of LTI system. First, we will learn convolution sum. Let us consider a LTI system which has input x of n and output y of n. This input x of n is any arbitrary sequence which is shown as below. This input sequence x of n has delayed impulses with different weights. Weights here are the amplitudes of this signal x of n. X of 0, x of 1, x of 2 are weights. Now, the same figure can be represented mathematically as x of n is equal to this x of minus 2 is a weight with delayed impulse. Impulse means impulse signal del of n, which exists at n equal to 0 having an amplitude 1. Now when I shift it towards left side by an amount 2, it becomes del of n plus 2, whose amplitude is 1. 1 into x of minus 2 is x of minus 2 at n equal to minus 2 plus x of minus 1 del of n plus 1 plus x of 0 del of n plus x of 1 del of n minus 1 plus x of 2 del of n minus 2. The same sequence now can be written as x of n is equal to summation k equal to minus infinity to plus infinity x of k into del of n minus k. When you substitute the values of this summation like k equal to minus 2, it becomes x of minus 2 del of n minus k value is minus 2. So n minus of minus 2, which is n plus 2, which I get x of minus 2 del of n plus 2. Similarly, all the other samples. Now, y of n can be represented for an LTI system as t of x of n. That is, when you give x of n to a system, LTI system, which is operated as t of x of n. Now substitute x of n as t of summation k equal to minus infinity to plus infinity x of k del of n minus k, which can also be written as summation k equal to minus infinity to plus infinity x of k operation on del of n minus k. Now del of n, as you know, is impulse signal. When impulse signal is given to a system, it becomes impulse response, that is output of this system when the input is impulse signal is called as impulse response of the signal. So t of del of n is represented as h of n, which we call h of n as impulse response of the system when the input is del of n to a system, it produces output h of n, which we call impulse response of a system. Now, this system is a time invariant system, hence T of del of n minus k becomes h of n minus k, means identical shift which is at the input and output side. So y of n can be written as summation k equal to minus infinity to plus infinity x of k T of del of n minus k is h of n minus k, which produces an important equation called as convolution sum, represented as y of n is equal to x of n star h of n. This star is a convolution operator, that is x of n convolution with h of n, which can be described as summation k equal to minus infinity to plus infinity x of k h of n minus k. So given x of n and h of n, you can find the response of the system. X of n is a input, h of n is behavior of LTI system. So h of n with x of convolved with x of n produces y of n, which you can find through this equation. Next, we will go through some of the examples of finding convolution sum.